Boeing Starliner spacecraft is going to remain on the ground for at least a few more days longer than originally anticipated. What they're doing is they're looking at a small helium leak that's connected to one of the reaction control system thrusters, which is a part of the propulsion system on the spacecraft's service module. The leak itself would not have scrubbed the May 6 launch attempt, but having additional time that they do now gives Boeing an opportunity to gain further confidence that it's within flight parameters. The upshot is, May 21st is now the new target launch date for the crew flight test, which will send astronauts Butch Wilmore and Suni Williams up to the International Space Station. So let's break this down into what Boeing is studying, what it hopes to learn from these tests, and of course, what's next for the CFT mission. As a refresher, Boeing's CST-100 Starliner is made up of two main components, the crew module up top and the service module down below. The leak I mentioned is located within the service module's pressure system, which is part of its overall propulsion system. Looking at this 3D rendering of the spacecraft, what we're talking about is right here. The blue spheres contain the hypergolic propellants, monomethylhydrazine and nitrogen tetroxide. These are the fuel and oxidizer for the service module, respectively. The orange cylindrical tanks contain the helium, which is used to pressurize the system. About a month ago, we spoke with Boeing's Mark Sorensen, who explained this within the context of fueling the service module.
We'll load monomethylhydrazine, a lot bigger tanks, takes a little bit longer to do, but the same kind of deal. Very deliberate, make sure that's all on there safely. And then we have to basically break everything down, because the next up is the oxidizer, the nitrogen tetroxide, and it's very important you don't get the oxidizer close to the fuel, right? Because they will explode. So we kind of have to do some, if you will, cleanup, if you will, to make sure that everything's ready for the nitrogen tetroxide to come in. So that comes in, again, very deliberate. We get that loaded up, and then we come in and we top off the helium tanks on the service module. And all told, that takes about 2 weeks to get through that process.
Starliner is loaded with more helium than is actually needed for a normal mission profile. And the reason they do that is to support the spacecraft's launch abort engines if needed. Those can come into play either during a pad abort, as demonstrated back in 2019, or a low altitude abort. A low altitude abort, as shown in this 2019 video from Boeing, calls upon up to 22 propulsion elements, including the 4 launch abort engines at the base of the service module. On a nominal launch without an abort, the excess helium is vented once the spacecraft gets on orbit. The leak that was noted by Boeing in its May 14th statement is connected to a flange on one of the 28 reaction control system thrusters. Those, along with the 20 orbital maneuvering and attitude control, or OMAC thrusters, are located within 4 structures around the service module called dog houses. Now you may be wondering about the timing of all this. Well, the Boeing team knew about this helium leak going into the May 6 launch opportunity. However, important to note that it was well within the criteria for launch according to Boeing for its Starliner spacecraft, so this was not the item that caused the scrub back on May 6th. That, if you recall from our reporting and that of others, was actually this.
The audible that I had reported earlier concerning the chattering sound is greatly diminished, but it is still present.
Roger.
The chattering referenced by the blue team at the pad turned out to be a valve on the Centaur upper stage of United Launch Alliance's Atlas V rocket. The valve is used to regulate pressure on the liquid oxygen tank. ULA President and CEO Tory Bruno said in a post-scrub briefing that they weren't able to determine in real time how close the valve may have been to the end of its life.
We've seen a sustained buzz like this on AV-53. We've seen short buzzes maybe 3 or 4 times. And what you would typically do is activate the solenoid that forces the valve closed, cycling the valve, if you will, and then you turn that off and you let it return, and it almost always stops.
And that's exactly what they did once Butch and Suni and the blue team left the pad area.
If this were a satellite, that is our standard procedure, and the satellite would already be in orbit. But that changes the state of the fueled Centaur, and we don't do that when people are present. And so our flight rules called for us to scrub and to take the crew off before we cycled that valve.
Ultimately, ULA decided it was best to return the rocket to the Vertical Integration Facility, or the VIF, which it did on Wednesday, May 8th. They then removed and replaced the valve on Saturday, May 11th. ULA also successfully tested that valve over the weekend. While they were inside the VIF, Boeing decided to take the opportunity to look more closely at the small helium leak. In the coming days, Boeing said it will, quote, bring the propulsion system up to flight pressurization, just as it does prior to launch, and then allow the helium system to vent naturally to validate existing data and strengthen flight rationale. Assuming then that everyone is comfortable with the outcome of that testing, they will then roll the rocket back to the launch pad with a May 21st launch date in mind. Meanwhile, after the May 6th scrub, Butch and Suni went back to Houston to be with their families and will return to NASA's Kennedy Space Center in the coming days. Boeing also noted that the mission teams have had time to look through all the data from the May 6th launch attempt, and with this, the helium issue being the only thing outstanding, they're otherwise ready to launch the CFT mission on the 21st. And so that's the latest on this flight. Of course, if you'd like to learn more about the Starliner program and the history of how we got here, you can click this video up here. If you'd like to learn more about the crew and their training, you can click on that video right over there. And if you haven't already, be sure to click this SFN icon over here to subscribe to Spaceflight Now. And for all of us here at Spaceflight Now, I'm Will Robinson Smith.